You're welcome to today's class. Today we want to look at union in C. We just concluded structure. The syntax of union is almost similar to that of structure, but there is a slight difference in the two. So what is union? A union is a special data type that allow all its members to share the same memory location. Unlike structure, where each of the members have their different memory location. In the case of union, all the members share the same memory, right? So that is what I want to show you in this class. So let's write a simple program to explain this concept. So this is like having a variable that will have different forms of appearance, right? So let's look at it. So the first thing I will do is the same thing. Um, include stdio dot h, and I will also include string, include string dot h, because I will need a tool from here. So I'm going to declare my union. The syntax of union is what? Union name, right? So data type member one, data type member two, and then we can have more. Then we'll close it. So this is just the syntax. So the keyword union is what makes it different from structure. So I'm just going to write a program in that nature. So let's write our program. So I will say union, that is the keyword. Unlike the other one, it was structure. So union, let's give it a name. We'll call it data. That's the name of the union, data. So inside this, we are going to have, let's have integer. Let's call it I. And then let's have float. Let's call it F. And let's have character. Let's call it string, str, and then assign 20 to it, right? Then we'll close our union. So this is the blueprint for our union that we have created. So the size of this union will be what? The size of the highest member. So in this case, integer is 4 bytes. Float is also 4 bytes. Character is 1 byte, but we have 20, so meaning 20 bytes. So the size of this data union is 20 bytes. So what you have is you have memory like this. This is the memory. Unlike structure, here you have this. Each of them, I will be here, F will be here, and then the str will be here. This is for structure. But in the case of union, these three variables will share the same space. So the variable that will be declared for this union will be having can house integer, float, or character, meaning one variable but different forms of appearances. So let's declare a variable for this data. So to declare a variable, we have to do it inside our what? Main function. So int main, right? Our main function. Then inside this main, I'm going to declare the variable for this union. So union data. This becomes the data type. Let's call it data. So we use lowercase data. So this is our variable. So the variable is what? Data. So this variable is going to house this I, it will house this F, and it will house this character, this char. But it's going to display them one at a time, meaning you won't have these three of them occupying this place at the same time. No. So the first person that will come in will be the what? The integer. This integer will come in. Then when float comes in, it will overwrite the integer. When the character comes in, it will overwrite the float. So if you don't print out as you bring them in, it means it is the last one that entered that will come out on the screen. If you try to print out the others, it will give you garbage value. So let me explain that to you with this code. So now I have declared my variable. Now I need to use this variable to access these members. So I will say data dot I, right? Integer. So assign 10 to it. Now, to put this out on the screen, the moment this enters and is stored in the memory, I want to print it out. So I will say printf. Because if I don't, let's call it data.I. Put this here. This one is integer, so %d/n. So this will be what? Data.I. Then I will assign value for this float. So I will say data.f assign 200.5. Then here I will say data dot for the string. That's why I brought this in. So I'm going to say string cpy string copy, right? String copy. Then data.str, comma, I'll say hello world. Okay. I don't know if you are still seeing. Let me write. So hello world. Then if I come here and I say print f and I say data.f, float is percentage dot, I want it two decimal places, 2f / n, comma. So this one will be what? Data.f, right? Now, I don't think you are still seeing down. So what should be here? I'm going to bring it here. So this place, I'm bringing it here. Now, following this same line, print f. Then I also say print f data.str. This one is %s / n. Then what should be there? This will be what? Data.str. I'll close it and then I'll do this. Then I'll say return 0. And this curly bracket, I will close it. Now, if you look at this, so what did I do? This is union. I created this union, and the name is what? Data. I have 3 members, integer, float, and string. This string is 20 bytes. Now I create the variable for this union, which is what? Data. I told you this variable data will have, so this is data. Now I will assign 10 to this place. That is for the I. So 10 will occupy this place. Then I will say printf data.I. So this one will print out. This one will print out 10. Then I said data.f. So this place will become 200.5. Right? It will override that 10 that was there initially. because these three are sharing the same memory. But I didn't print out this one on the screen, so you will not see it. Then I did this string copy. I used my string copy function to copy this hello world into this data.str. Now, the variable, which is this data, is accessing this member and is going to store this hello world in the same memory. So the hello world will be stored here. It will override that f, that float. Then I say printf data.f, trying to access data.f. Because the binary value that is in the memory now is to be interpreted in the string format specifier. But because you are asking the compiler to interpret what is in this location, because this hello world has been converted to binary, now you are asking it to interpret it from the realm of float. It's going to give you garbage value. So this one will give you garbage value. Garbage value, meaning it will just write all types of numbers that won't make sense because it doesn't understand that binary in the realm of float. Then I will say printf data.string. So this one will now print out hello world on the screen. Hello world. That is together, but just because you might not see. So it's going to print out hello world on the screen because at this point of asking it to print out what is inside this place, what is there is hello world. It has overwritten all the other values that were inside this place before. So that is the concept of union when you want to minimize space. So if I want to print out all these values, it means I have to call my print function at every interval of assigning values to what? To each of them. So here, data.I, 10, I will call my print function to print that on the screen. Then I will give data.f to it. It will overwrite what is inside that place. I will print it out. Then I will copy the string. I will print it out. That is how I can print out the 3 on the screen. But if not, if I allow the last one to enter, that will overwrite every other values that were inside the memory location. So that is the concept of union, right? So let's go to code blocks. Let me demonstrate this for you to see. Okay, so this is our code blocks on union. So this is the script that I wrote on the screen. You can see I created my union, and then I created the variable for the union, which is data, and I assigned values to each of them. But as I assign the value, I print them out. I assign the value, I print them out. Then, I try to, after assigning the last value, which is what, the string, and now try to print out the value of I. This one is going to give me a garbage value. You will see it. Then I also introduce printing out the size of the union. So the size of the union will be the size of the largest member, which is what? This string, so which is 20 bytes. So let's run this script for you to see the output. So I drag this up, take this up a bit. Okay, so you can see data.I, printing out data.I out. It gave me 10 because I inserted 10 in it. Data.f gave me 200.50 because I said two decimal places. Then string copy, pull in hello union. So I printed it out and it gave me hello union. Then I tried to print out. So right now, what is in that space is hello union. Now I'm trying to print out data.I. Data.f overwrite data.I. And then the string overwrite the data.f. So what is in that memory right now is hello union. So trying to interpret it in the realm of integer using this format specifier will give me this garbage value 1819043144. It doesn't make any sense. That's what I mean by garbage value. Then I try to check the size of the union. So size of union is 20 bytes, which is the size of the largest member. So the largest member is what? The string, which is character, and the value is 1 byte multiplied by 20. So that is 20 bytes. So that's why you're having 20 bytes. So that is what I want to show you in this class. So till we see you in the next class. Bye-bye.